All right, let's break down the fundamental grammar of Python. If you've ever wondered why your code works, or let's be honest, why it doesn't, it almost always comes back to two core building blocks: keywords and operators. I bet we've all been there, right? Especially when you're just starting out. You run into some kind of error message that just makes you scratch your head. You write something that feels like it should work, but the computer just says, nope, not happening. Maybe it looked a little something like this. You try to create a simple variable, you call it for, you try to give it a value, and bam, syntax error. It's frustrating for sure, but this isn't a bug. This is actually Python trying to tell you that you've accidentally broken one of its most important grammar rules. And by the time we're done here, you'll know exactly which rule you broke and why. So, to really get what's going on with that error, we need to stop thinking about Python as just a tool and start thinking of it like a language. And just like any language, English, Spanish, you name it, it has grammar. It has a set of rules that tells us how to structure our sentences, or in our case, our lines of code. In English, we have nouns, they're the things, and we have verbs, they're the actions. You can't just toss them together any old way and expect it to make sense. Well, Python's the exact same. It has special words that define its structure, kind of like nouns, and it has symbols that perform actions, just like verbs. Let's meet that first type now. And that brings us to keywords. Think of these as the absolute golden, unbreakable rules of the language. They are special, reserved words that Python itself uses to understand the logic and the flow of your programs. The really big thing to get here is that these words have a job that is hard-coded right into Python's DNA. This means you can't just decide to use them for something else. Nope, they are reserved for official Python business, and Python business only. This slide really lays it all out. On the left, you've got your keywords. They're fixed, they're unchangeable. On the right, you've got identifiers. Those are the names we get to make up for our variables and functions. And that right there is exactly why our first example, 4 = 10, just completely fell apart. The word for is a reserved keyword, so you can't use it as your own identifier. Simple as that. Now, don't worry about memorizing this whole list, but you'll definitely start to recognize these guys. You see keywords for values like true and false. You see them for controlling the flow of your program like if and while. And hey, some even act like operators like and or. And speaking of operators, so if keywords are the structural rules, the nouns of our language, then operators, well, they're the action words. They are the verbs of Python. These are the symbols that actually do things with your data. Basically, an operator grabs a value or two, we call those operands, performs some kind of operation on them, like adding them together or comparing them, and then it gives you back a result. Okay, let's start with a group we all know and love from way back in the day, arithmetic operators. Yep, these are the ones you've been using since grade school math class. They handle all the basic calculations. You've got your usual suspects here: plus, minus, multiply, divide. Python also gives us some handy extras, like the double asterisk, which is for exponentiation, to the power of. Pretty straightforward, right? All right, next up, comparison operators. Now, these are super important because they're what allow our code to actually start making decisions by asking questions about our data. These let you ask things like, hey, is A bigger than B? Or are these two things exactly equal? And notice that double equals sign double equals for comparison. This is a big one. A single equals, like A = 10, is for assigning a value. A double equals asks a question, and the answer it gives back is always either true or false. But what happens when one simple question isn't enough? What if you need to ask something more complex? Well, that is where logical operators come into play. They let you chain multiple comparisons together to get a single true or false answer. With and, both sides of the equation have to be true. It's kind of strict. With or, it's a bit more relaxed. Only one side needs to be true. And then there's not, which just flips the whole thing on its head. True becomes false, and false becomes true. Okay, so we've got our keywords for the rules and our operators for the actions. But when you put them all together in a single line of code, how in the world does Python know what to do first? Well, it all comes down to something called operator precedence. It sounds fancy, but it's really just a formal name for the order of operations. You remember PEMDAS from math class, right? Please excuse my dear Aunt Sally. It's the exact same idea. It's a set of rules that tells Python which symbols to pay attention to first. All right, let's put it to the test. Take a look at this expression. What do you think happens here? Does Python do the addition first, or does it do the multiplication? Go on, take a guess. What do you think the final result will be? And the answer is 610. But why? It's because the multiplication operator has a higher precedence, a higher priority, than the addition operator. So Python calculates 20 times 30 first, which gives it 600, and then it adds the 10. You can see how understanding this order is absolutely crucial for writing code that works the way you expect it to. So, if there's just one thing you walk away with today, let it be this. Keywords are the words that define the structure. Operators are the symbols that perform the actions. By really understanding these two basic building blocks, you're not just copying and pasting code anymore. You're actually starting to speak the language. You know the rules and you know the actions. So the only question left is, what are you going to build? Thanks for sticking with me on this one.